All right, so what we're going to do today is we are going to use what we've learned about area and its relationship to side length to find the length of this segment of line right here. But before we can find the relationship between area and side length, we have to identify area. So we're going to go back a few days and use what we learned about finding the area of a rotated or tilted square. We're going to create a square from this segment. We're going to then enclose it in a larger square. We're going to compute the area of the larger square, and we are going to subtract out the area of the smaller triangles enclosed in the larger square but outside of the inner square. Once we have the area, we're going to take the square root of the area, and that is going to give us our segment length. So, to start with, we're going to turn this into a square, and you're going to want to use a ruler so that you can be more precise. Then we are going to enclose it in a larger square, and I would, again, urge you to use a ruler to be more precise. And then we are going to start by computing the area of the larger square. So we know this is going to be 1, 2, and this is 1, 2, this is 2. And so the area of the larger square is going to be base times height, 2 times 2, 2 times 2 equals 4. So that's going to be the area of the purple square. Okay, purple square. Now what we need to do is compute the area of these triangles inside. Okay, and there are 4 of these little triangles. So we're going to compute the area of one of them, and then we're going to add them together. So one triangle, this is one segment, 1. This is one segment, 1. And the area of a triangle is base times height divided by 2. Or that can be written as base 1/2 base times height. So either way. So we're going to have 1 times 1 divided by 2 equals. 1 times 1 is 1, divided by 2 is 1/2. So each of these is going to be 1/2. So 1/2, 1/2, 1/2, 1/2. So, all right, so we've got each triangle equals 1/2 in area. We have 1, 2, 3, 4. So we have 4 times 1/2 equals 4 times 1 is 4 over 2 equals 4 divided by 2 is equal to 2. So now we have the area of the triangles on the outside. We have the area of the larger rectangle. Take the area of the larger rectangle, 4, and we subtract the area of the triangles on the inside, 2, and that will give us the area of the tilted square. 4 minus 2 is 2. So this is 2. To find the side length, it's very simple. Once you know area, the side length is the square root of 2. If we were going to be precise, we would get out our calculators. So if we're going to be more precise, we're going to get out our calculators. We're going to find the square root, which is a blue function. So we're going to hit the blue key, square root 2 equals, and we're going to get 1.414213562. Remember that this is an estimation, that this is a non-repeating decimal that goes on forever, and if we multiplied 1.414213562 by itself, it would come up with a number very, very close to 2, but not exactly 2. This calculator would actually round it up to 2, and it would appear like 2. But it is indeed an estimation. So, to review our process, to find the segment length, we create the square. We enclose the square in a larger square. We find the area of the larger square, 4. We find the area of the individual triangles, 1/2. We multiply that 1/2 times the number of triangles enclosed in the square. 4 times 1/2, 4 divided by 2 is 2. Then we take the area of the larger square, subtract the area of the triangles 2. 4 minus 2, 2 is the area of the square, and our side length is going to be the square root of the area, square root of 2, and the square root of 2 becomes 1.41. Okay, and that's all you have to do.